and I've said this already too, that if you convert all the ADP to ATP and this gradient builds up, okay, that means NADH isn't being consumed. That feeds back to the Krebs cycle, and that slows down the Krebs cycle because those dehydrogenases won't be able to work if there's no NAD to donate electrons to, if it's all in the form of NADH. This all happens when you've converted all the ADP to ATP. So at very high levels of ATP, if this is high, there's very little or none of this. A high ratio here shuts down respiration. Another fancier way of saying that is energy charge, a higher energy charge. So if this ratio is high, if we plug those numbers into our energy charge, the energy charge equation, energy charge is just another way of saying lots of ATP. If energy charge is high, then the respiration rate goes down. And I just want to kind of tie that to our previous discussions. We've said this before, that the energy status of the cell, the energy charge, controls things. So if you've got a high energy charge, what we're saying here is this classic catabolic pathway of glycolysis and the Krebs cycle and mitochondrial respiration slows down the higher the energy charge. And if you go out to an energy charge of 1, by definition, if energy charge is 1, that means it's all in the form of ATP. There's no ADP. You can't do any oxidative phosphorylation anymore. And the whole pathway from glucose to oxygen, in theory, would shut down. So this is the pattern typical of energy generating catabolic pathways. They're highest when the energy needs of the cell are greatest. When energy charge is low, they're operating at full speed. That's when you're going to do glycolysis and Krebs cycle and mitochondrial respiration. If you move up here to high energy charge situations, those pathways are no longer needed. They drop to low rates. It's the exact mirror image when you look at biosynthetic pathways. These are pathways that use up ATP rather than make it. The cell shuts them down at low energy charge. You're not going to make some expensive lipid fatty acid or something if your cell is almost out of energy. It's only when the energy charge is high and there's lots of available energy that those get rid of that. So you see these two mirror image patterns of metabolic control.
So you're saying if the energy is low, then the catabolic will turn on?